if this is your aircraft, weight of aircraft is acting through a point called CG. And the point through which the lift acts is called center of pressure. Now, obviously, the point of application for both the forces are different, correct? So, for example, if this is a rod, you apply X force here, X force at this point, and X force at this point, upward direction. What would be the movement of this? It will go this way. So this is called turning moment, right? So any force, when two force acts at a different application, point of application, they causes a turning moment. And the product of that moment is the force applied into the arm length. That is the product of that, whatever the magnitude of the turning moment. Now, if my CG position is forward, what happens to stalling speed if we see a CG position forward? If our CG position is forward, then lift, your weight is acting, the weight of aircraft is concentrated at the forward position. So it will try to push the turning moment, it will induce a turning moment, causing aircraft to rotate this way. This is called pitch down moment. So weight and lift couple, if CG is forward, produces nose down pitching moment. Correct? This is by whom? Lift and weight couple. To address this situation, we have another couple, thrust and drag. They are also in opposition. So if this is your thrust, which is acting in forward direction, this is your thrust, which is acting in a forward direction, and then we have drag. The drag line is on the top of thrust line. The drag line is on the top of the thrust line. So this drag line or a drag produced by the aircraft try to push the tail down. This try to push the tail down. So if this try to push the tail down, what would be the movement of the pitching moment? Kya hoga? The pitching moment would be nose up. So thrust and drag couple produces nose up pitching moment. Now this will compensate for your nose down pitching moment produced by the lift and weight couple. So this is producing nose up pitching moment by whom? Thrust and drag couple. But in reality, what happens? Your lift and weight couple is way stronger than the thrust and drag couple, which technically means aircraft will still remain in the nose down attitude. This will cause you can say instability. Your aircraft inherently should be stable, but when its tendency is to go nose down, that means it is unstable. Now to provide this stability to the aircraft, you have the tail plane. It is the tail plane which provides the downward balancing force. This tail plane creates downward balancing force. Yeah, you can say lift downward. Now, this downward balancing force at the tail will again cause the nose up pitching moment. So this will further raise the nose up, and this is downward balancing force. By whom? Tail plane. So now you can understand how important role the tail plane plays in an aircraft for a stability purpose. Our point of discussion was what happens to the stalling speed of aircraft while CG is forward. When CG was forward, this was producing nose down pitching moment. That's why your tail plane has to produce downward balancing force to cater for that.
The downward balancing force मतलब कि nose up.
Basically, ऐसे लगा, it is pushing the tail down, right? So it will raise the nose. Now, as we have studied in our previous lessons, any kind of lift that will cause a induced drag. Lift is induced drag is a byproduct of lift. So this downward balancing force is basically a lift. So can you now tell me with forward CG, what happens to your induced drag? So your induced drag is more. Induced drag is more. Stalling speed would be? If your drag is more, you require more lift to fly at the same speed, right? So lift ज़्यादा चाहिए आपको. So your stalling speed would be higher. Correct? If your induced drag is more, what happens to fuel consumption? ज़्यादा fuel consume करेगा aircraft because drag is anyway the cost to an airline. It's money. So your induced drag is more means your fuel consumption is more. If your fuel consumption means the fuel consumed per hour is more, then what is the endurance of the aircraft would be? Yes. What is endurance? Endurance is endurance is the time duration in which aircraft can be in air with a given fuel. So for example, if you have a 1 ton of fuel, you can remain, let's say for example, 2 hours in air. So your endurance becomes 2 hours. Now when your induced drag has increased, the per hour fuel consumption will increase. In this case, what would be your fuel consumption? Can anybody tell me? 1 ton fuel you have and it is consumed in 2 hours. So what is your fuel consumption? Half ton per hour, right? You are consuming half a ton per hour. So in this situation, you are consuming half ton fuel per hour. That is your fuel consumption. When you because of CG being forward, your fuel consumption has increased. Let's say for example, fuel consumption becomes 1 ton per hour. See, this will not happen. I'm just telling you, just an example. Itna change nahi hoga. So fuel consumption in 1 ton per hour. Now what would be your endurance? How much it would be for this situation?
1 hour.
How much it would be?
1 hour.
Exactly 1 hour. First you had 1 ton which was lasting for 2 hours. Your fuel consumption was half ton per hour. Now your fuel consumption is 1 ton per hour, means this will last for 1 hour. So your endurance is 1 hour. So that means if your fuel consumption has increased, your endurance of the aircraft will reduce. Okay? Now, there is something called range also. जैसे endurance होता है, how long you can fly with a given fuel. In range is also how many nautical miles you can cover with a given fuel. Okay? Now your drag has increased. So that, yeah. So your range, because drag has increased, your fuel will be consumed much faster. So the range you will cover with that given fuel will be less. So by having CG forward, your range also reduces. Any doubt? Clear? So these are some of the effect, or also we have spoken about controllability. As I said, if your nose is heavy, if your CG is forward, your nose is heavy, you will require a lot of force to counteract that. So that means to control the aircraft, it will be easier or difficult? It will be difficult. So your controllability would be poor. Poor controllability. 8. If any material or anything which is more controllable, means you can easily maneuver that thing, it will be less stable. Correct? So whenever your controllability is more, your stability of that particular thing would be less. So in our aircraft, if the controllability with CG forward is poor, that means stability would be good. So it produces good longitudinal stability. So write down good longitudinal stability. Any doubt with that?